Hello everyone, welcome you all. Myself Vandana. I am from Sri Venkateshwara College of Engineering. Today I am going to discuss a subject called as a mathematics on the topic linear algebra. Introduction to linear algebra. Linear algebra is a branch of mathematics that mathematics deals with the vector space and a space and linear equations. It provides a framework for solving a system of equations and studying transformations. Linear algebra is essential in fields such as physics, computer science, and data analysis. Vector and vector space. Vectors are mathematical objects that have both magnitude and direction. They can present as a arrow or a columns of numbers. Vector space are the set of vectors that satisfy certain properties such as a closure under addition and a scalar multiplication. Matrix and operations. Matrix are rectangular arrays of numbers. They are used to represent a linear transformation and solve a system of linear equations. Operations on matrix including addition, subtraction, scalar multiplication, and matrix multiplication. System of a linear equation. A system of a linear equation consists of multiple equation which the same variables. It can be represented in matrix from X is equals to B, where A is a quotient matrix, X is the variable matrix, and B is the constant matrix. Solution to the system can be found using a method like a Gaussian elimination or a matrix inverse. Eigenvalues and eigenvectors. Eigenvalues are scalar values that represents the stretching or a shrink factor of a transformation. Eigenvectors are non-zero vectors that are only scaled by the corresponding eigenvalues. They play a circular crucial role in diagnosing matrix and solving differential equations. Matrix decompositions. Matrix decompositions break down a matrix into simpler forms to simplify calculations. Example including a LU decomposition, QR decomposition, and a single value decomposition. These decompositions are used in a various applications like solving a least square problems and image compressions. Vector space and subspace. Vector space are the set of vectors that satisfy certain properties such as a closure under addition and a scalar multiplication. Subspace are subsets of a vector space that are also vector space. For example of a subspace including the solution space of a homogeneous system of a equation and the column space of a matrix. Inner product space. Inner product space is a vector space equipped with the inner product. The inner product measures the angle between vectors and allows for the definition of norms r and distance. For example of inner product space is including a Euclidean space and a function space. Linear transformation. Linear transformations preserves a vector addition and a scalar multiplication. They can be represented by matrix and have important properties like injectively and surjectively. Examples of linear transformation including rotations, dilations, and projects. Orthogonally and orthogonality and orthogonal projections. Orthogonal vectors have a dot product of 0 indicating a 90-degree angle between them. Orthogonal projections are transformations that map vectors onto a subspace along the orthogonal component. Orthogonal bases are orthogonally matrix are commonly used in a computational involving orthogonality. Determining and Determinants and Crame's rule. The determinant of a square matrix is a scalar values that provides information about the matrix properties. Cram, Kramer's rule is a method for solving a system of a linear equation using determinants. Determinants are used in various applications such as finding the area of parallelogram and calculations the calculating the inverse of the matrix. Eigenvalue decomposition breaks down the matrix into eigenvectors and the diagonal matrix of eigenvalues. It is used to simplify calculation, including a repeated matrix multiplication and power. Eigenvalues decomposition is essential in areas like physics, signal processing, and data analysis. Applications of linear algebra. Linear algebra has applications in various fields such as computer graphs, graphics, machine learning, and cryptography. It is used for image and single processing, pattern recognition and data analysis. The linear algebra provides a foundation for understanding advanced mathematical concepts and problem solving techniques. Importance of linear algebra. Linear algebra is a fundamental mathematical subject that underpins many areas of science and engineering. It provides a powerful framework for solving problems involving systems of equations and linear transformations. Understanding linear algebra concepts and technical is issued for future study in advanced mathematical and appropriate areas. Thank you, everyone.